Okay? All right, so there's three things that are very straightforward and obvious. You've already talked about them before in Stats 1 if you want to talk about it. I'm going to go over it again so it makes some sense to when we do those evil confidence intervals that, of course, Ryan is saying I have no confidence with confidence intervals. Though I gave some of it, it alludes to it in a second. Okay? So the first thing is pretty straightforward, is what's called mean. Don't be so mean, Murmer, right? And we denote this as either mu, and today we're going to talk about it as x bar. And guys, whenever you see the bar on top of any variable, it means the average. Okay?
Yep.
Pretty good? All right, so I'm looking for another marker, and I have it right here. And I do have some writing on there. Sometimes it's written a little differently, and I think you already know how to calculate the mean, right? And that's just what? I can write it this way if I want.
NP? Or
Yes, not NP, no, because that's we're using that as an average for Poisson distribution. We're not doing distributions anymore. We're doing what's called central
tendency?
tendency, or variant dispersion, measure dispersion, and or the central limit theorem. And then this one here would be something like this: I equals 1 or to infinity. Okay, and it could be anything. So what it really means is x1 plus x2 plus ... x of n over the number of choices. Okay, really straightforward, nothing serious. If all the data counts is the same thing, that means if each individual data counts as one unit or whatever it is. Okay, it's really obvious. Okay, no big deal. I think it's on the sheet and so on. Not bad. So easy. We'll find the average of something. Okay. Now, sometimes what they like to do is you do that test question thing, remember? Like Eileen comes and says, hey, I need a 97 in this class so I can get into the University of Florida or whatever it is. What's a good university in Miami? Miami, in Florida?
UF.
So I was right, huh?
Yeah.
So if she wants to become a pharmacist, maybe, right? No. Chemical engineer? No. Yeah, good. Yeah. All right, now we're talking. I started off the same way when I was young and had some hair. Not all hair, like you, Mr. Treble, but some hair. And I started as a chemical engineer, and then I went right into chemistry and math and biochem. Never.
Remember, you never saying that you haircut.
No. Well, if we were in the military, right? Mine's even too long.
If he was telling Orion to get a haircut.
So average, right? So if you had to figure out a certain, let's say, average grade, you know how to do it. But let's say if one of these counts more than the other, for example, Eileen would say, hey, my last test out of 4 tests, the 4th one, would cost twice as much as the other. What do I need to do in order to get a 95 in the class, right? So Eileen, give me 3 or 4 grades. Give me 3 grades. Go ahead.
97.
Here we go. 97.
85.
85. No, she'll never get a 0. What's the third one? 10.
6.
I'm just not shades on my
79.
79 is 60. Okay.
Come on, man.
And so what we're going to be doing is we're going to say the last one
2x.
is going to be twice as much as the other one. And then we want to find out, Eileen, what do you want to get? What's the grade you want to get?
I want
95?
no.
100?
I want a 99.
She wants a 99 left balloons,
You
okay?
won't be able to get 100.
Let's see if she can, without bonus and so on, right? So how many choices are there here on top now, on the bottom? Not the top one. 1, 2, 3, 4, 5. Right? Because this counts twice as much, right? Yes, it does. But it's one test, but it still counts twice as much.
So it's counted another thing?
Yeah. Because each one of these counts as, quote, 1, and that's twice as the other.
Okay.
So now you go 99 times 5, and everybody knows 99 times 5 is 495.
Yeah.
Is that right? Okay. And then the sum of these numbers are, besides me saying, is what? Anybody? A lot. Okay, a lot. Anything? Subtract a lot. And then 261.
This is the math I can get behind.
And then divide both sides by 2, right?
Something.
Which is the 130.5
So she needs a 131 approximately for x, right?
for a 99.
For a 99
You need to
average.
get 130.
Yeah, a
So
lot
it's
of
not
extra
going to
credit.
happen, right? It won't happen unless there's like super bonus, super
Yeah.
sandy bonus, and so on. All right?
Unless you get like 5 grades.
Sorry?
Unless you get a bunch more grades.
Unless you got a bunch more. Yeah, exactly. And that would lower this value for that specific data. Okay? Yes, sir.
Or if you get extra credit on a test and then extra credit homework.
That's even better. So you can see the idea how you can accumulate. But in essence, you're just doing the average, right?
Yeah, but
No
if
big
you're
deal.
gonna
No big deal.
pay extra credit,
I
you
just-
need 30 pounds for 5 extra.
I just added the extra credit, yes. Does Miss K do extra credit?
Not that often.
Not that often? Yeah. Now another one, right? So you guys know normal distribution, X bar is right here, or mu, and that's our zero plumb, I call it the plumb line, right? Where it's symmetrical, it's not skewed in any manner, and it's choices of roughly 28 to 30 of whatever the events are. Grades for Ms. Kemi, going for a PhD hopefully. Oh, I'd love to see that. Should be like same length of hair but all white. Okay? Because when you see people get doctorates and so on, you see them, they're all like, young and everything else, energetic. Then they get their bachelor's degree, they still feel good. Then they get their master's degree, they're like, oh. And then they get their doctorate degree, and there's people like doing this, like, yo, It's pretty
How
fun.
many got my doctorate at 24?
I can't wait to see it, Dr. Turing. I can't wait to see it, all right? So mu is here, right? And so anything that can do from the mean is a variance, right? So we're going to call that the square root of the variance is sigma, right? Negative sigma and positive sigma, here we go. And for the sigma, we call that the standard deviation. No big deal, deviating from the mean.
Yeah.
And we're going to use the formula, which is very similar to using the mean, and we're going to subtract each individual data set from the mean and divide by the number of choices. Wow. What does that mean, right? Which one?
SD.
Standard deviation.
Okay.
And that's on the paper.
And that should be on the paper somewhere, right? Okay?
It's on the paper twice.
Of course. And now I can derive that formula if you wish, but I don't think you want me to. Because I'm ready. I'm going back in 2005, I think, maybe, one of my graduate statistics courses, but I don't think it's necessary. The formula will be given to you. Now, this is if there's a difference between the sample and the population, right? And it should say that there, probably in that little box. I'm not sure. Does it say there? Right? One is S and one is sigma, okay? And if it's sigma, I don't think you use what's called DF, degrees of freedom. I don't think you're going to have anything to do with degrees of freedom.
Well, the only difference between
They just use
S
that.
squared and sigma squared is n minus 1 on the bottom.
That's what we're talking about, right? Yeah. Anybody know why it will be n minus 1 here to find out the bottom for S? Anybody want to know why?
That's a sample variance.
Right. The biggest thing is because within all those multiple, like 10,000, 20,000, remember the 80,000 with the marriage thing or something? I can't remember in the birthdays. Well, 80,000 people, one of them or some of them are going to be so close to the mean, they're going to actually skew this in a certain manner. So what we do is we subtract that off. It's called subtracting off the mean in order to get a better representation with more confidence and less uncertainty. Okay? I can't help myself saying that. Okay? So this is when usually n is less than 30, okay? Now I can prove it to you, but you don't want to know, all right? So all we have to do now is find out, let's say there's so many test scores and everything else, how much they deviate from the mean, yeah? Remember that curve thing?
Yeah.
Now I'll tell you this, hopefully I won't, and I'll talk about variance in a second, which is about 10 minutes, less than 30 seconds. What's that? Oh, nothing. I remember I took a stats class and everything else. No, I only took like about 7 of them, sorry. I went into pure math, I don't know why, all right? That's just my fault. The big thing was, one of them was, hey, the guy said, Dr. Salter said, hey, do you want to have curve or do you want it straight? Everybody said curve. He says, fine. That means anybody that has less than a 90 gets an F. That's where he started the curve. You see what's going on? So people were doing something that's, I shouldn't say on tape, okay? They were sweating bullets, okay? And the biggest thing was, if you got a 90, you got an F. If you got a 95, that's a C. So it was one of the worst ways. So if you missed like one question, you're down to a C. That's how hard you made the test, or how the class was. Because they were, I would say, go straight, go straight. Go whatever you got, that's what you do. You should go, I call it going straight, all right? Because you don't curve it. You've heard that law, just bump it up or push it down based upon the mean. Well, I guess nobody was a statistician at that age that I was compared to my class. But they didn't listen, but guess what I got in the class anyway?
100?
No.
Mean.
99 actually. Sorry. Okay, I got you. See? I don't know. I missed 2 questions. No, that was an A. That was an A.
Like a low A?
No, he gave me the A. I got a straight A.
Gave you 100?
100 was A plus. A was a 99. A minus was a 98, 97, 98.
Wait, were the others weighted differently?
Well, the test, he weighted the test and then he and then you just put it into the formula.
Is it A plus way different than A?
Depends upon the school.
Well, now-
Sometimes it means
yeah.
nothing other than on this form. But like Ms.
Yeah.
Caitlin said, yes, it can be. If, let's say an A is a 4, right? 4 out of 4. If you go A plus, it's sometimes 433 or 417. It's because it's highly exceptional. Depends upon the school. NMSU changed it so an A and A plus, same thing. And my doctoral work has like all A's and all A pluses. But I was so ticked off about that because I would have over a GPA of over 4. Now it's only sadly 4. Okay?
Yeah.
I'm disappointed. Okay? That's it. So let's talk about just a couple of ways how to do this. And I think you guys already know how to do this. So I'm going to just go 1, 2, 3, and 4, right? Is that okay?
Yeah.
Call that X1, X2, X3, X4. Now we're not going to do 95, 97, 99, or whatever. This doesn't matter. So the first thing is I got to find X bar. Rocket science here, right? What's X bar?
The mean.
And that it would be?
The mean.
And that is?
All of them divided by number.
The sum of all of them by 4, right? Not 4 minus 1, right? Okay, so what is that? It's 10 over 2.5, right? So far, so good? That is the mean that goes right in there. Now, I'm going to write it a little differently. I'm going to do it this way. Is that okay? You guys already know what the sigma notation means. It means the sum. Sum of their difference of squares, okay? So that means what? What's the first one? X of I is what? Well, it's the first piece of data, which is what? 1. 1 minus 2.5. Look familiar? I square that sucker. Now what's it say? Hey, you add it. Sorry, I did that way, right? Next victim, 2 minus 2.5, right? Squared plus.
Oh.
Oh!
I remember this.
I remember this. Murmer made us do this stuff longhand. I hated for that.
Wait, are we squaring it because of the E thing?
We're doing this. We're doing orders of
Oh,
operation.
the whole, okay.
Right, that's why I wanted to go over this, okay? Because I thought, like, you know, everybody knows this. I'm like, I remember this. I forgot this, okay? Then the next victim, right? And then the before, thank you. Minus 2.5, quantity squared, all over, what's the number of dudes or people in the 4. And it's inside the radical, right? All right?
So we have to do XI for all of them?
Yes, because what is it saying? It's saying, I'm the mean, how far is everybody from the mean?
Okay.
Yeah? Yes, sir.
Is there a way you can do it without like that craziness?
Yes, you can. You can actually do it using this one right here.
I can't read that.
It's over here. You have, well, you can come on over here and read, okay? But you can. But I prefer this method.
I think it's like
This is-
similar amounts of work though.
Yes. What's one? So what's the result here? Anybody? So it's negative 1.5.
Yeah.
What's 1.5 squared? Everybody knows what's that? 2.25. Yeah.
2.25.
There you go. So that's 2.25. And then this is 0.625. Yes. Yes.
0.25.
This is 0.25. Because oh, it's 0.5 in the square for 0.25. I squared it again. Plus that's point again. 0.5.
0.25.
0.25 again, right? And that's 1.5, and then this is 2.25, right? All over 4.
Wait.
I took the difference, and then I squared it. That's what we did. Took the difference, squared. Took the difference, squared, et cetera, et cetera. Cool? Now, Billy, add those up for me, and then divide by 4. Tell me what you got. So, she got 1.25. Now, what does that sigma tell me? Or tell us? Tell
The
you.
standard deviation.
Standard deviation.
Isn't that variance we have to
No, not the variance.
You square
Square
it.
root the whole thing though.
If we square rooted it, we get standard deviation.
Oh, that's okay.
Inside
I
the
didn't
radical-
square root it, so that is
oh.
the variance.
Yeah.
Oh, I didn't know that. She told me. So this is the variance, right? So
Right.
the square root of 1.25.
Yeah.
Yeah.
That's sigma squared, right? And then what's the square root of 1.25?
Square root of 1.25.
1.12.
Yes. 1.12 again
Yeah.
is sigma. All right.
That's the standard.
Yeah.
Now, variance is just the square of the dispersion, which is standard deviation, right? Why do we care about variance? I don't know either, but I'm going to tell you. Didn't Sandy give you a sheet on that stuff? Because you get this guy here, right? And you're like, well, what do I need in anything else, right? Big deal. I don't need anything else, right? Nick's like, hey, come on, man. Don't need nothing. I can just make the graph and everything else, right? I can do something like this, right, guys? Cheesy picture. There's my mean, and every what? Every sigma is 1.12, right?
Yeah.
That's a negative sigma, that's a positive sigma. Then you get 2, and remember, the percentages in here are 64%. I believe that this is going to be 95%.
68.
68.
Is it 68?
Yeah.
Oh, 34, that's right. 68, 95, and then 99, right?
Yep.
99 left balloons, okay? 99.6 or just 99? I can't remember.
99.7.
7. Okay? And there's a sigma factor to figure this out. And it's on the back of the sheet, right? So why do we care, again, about sigma squared is equal to what? Just 1.25, right?
Mm-hmm.
Right? It's the guy inside the radicant? Yeah? Yeah.
Yeah.
So why do we care about this guy here? This is important, but why do we have variance? What's the big deal about variance? Nick?
It tells you how much it varies.
That's right. It's what? What's the main reason why?
It's squared.
It's the variation that, if you think about it, remember this a long time ago when math was fun and easy and you could fall asleep all day?
Yeah.
Remember that? There's something that's called the sum of variance squares. The whole thing, when it comes to the slope, doing all that stuff, the average of the least squares and so on, is based upon the individual estimations of each individual variance. So that means in order to draw this cheesy line, Mr. Tribble, right, whatever it is, and have a y-intercept, y equals mx plus b, where what? The slope is equal to k, which is the line and everything else. I could just have a shotgun effect of everything else, right? And so what I can do is I can actually use regression models to figure out the best line fit for this thing. Hence, I'm finding the variance of everything associated to make that line. That's mx plus b right there.
So variance helps you find the line of best.
Everything. It tells you everything. So Sammy wrote a whole thing on it and so on, and then he told you like a business model and so on, because it's a singular sheet, sir. Okay? So that's essentially what I wanted to go over. I mean, I think it's straightforward. I have like millions of problems, of course, but you know me. I'm not going to like confuse you or befuddle you on this, all right? So, one, it generates the normal distribution, the Gaussian curve and so on. And two, it tells us the relationship between the mean and the variance. Okay? Not bad, right? So this one is a easy peasy class. I wish I could do this with my left hand, but I can't. I need surgery. Okay? Yeah, it's a long story. All right. So, not bad. This looks pretty straightforward.
Mm-hmm.
Should I put one up for you guys to practice, or you feel that confident?
I think we have time for that.
Sure. Give us a data set. Let's
Give you a data set and then rock and roll. I agree. We'll try one of them, okay? And yes, Mr. Tribble and so on. Oh, look at that murmur. Man.
Mr. Murmer.
When aren't you prepared? Right? There are days. Okay. So I'll move this up. La Luz, please. And I know that this is not a bad one, and I'm going to show you there's a program, if you can get the lights for me.
Luces, por
Either one of
favor.
them. Spanish. I have someone that's, she thinks she's a Spaniard, okay? She does, but she's not. But she, long story short, she was in Mexico, she served, her undergraduate degree is also in Spanish, and I made her do a dual minor. She hated me for it.
Can't read those numbers.
I'll tell you in a second. I'm going to magnify it, okay? It just won't. The computer's slow, as you can tell.
Mm-hmm.
And so I'll let you guys try this out, and then I'm going to put this in something called stat math, and then I just put it in, and it gives me everything. But I want you guys to try the long form of it, and if I won't give something like this long on the test, but I'll give you like 4 or 5 numbers, just like I did last for passing. So you understand where it comes from, okay? All right, so here we go. I can make these numbers. I can't see this number. Remember? Let's get the program.
Mr. Murmer.
That's me.
So this isn't a worksheet that's printed out.
I just want. Yeah, I couldn't get it
Okay.
because Mrs. Moore is
not here.
not here. Not it. So the right. Let's see here. So you can see
One
it.
too big. One the same size.
The end. Is that okay? And then I'm going to color them. Oh wow. Okay. Can everybody see it? Now I know there's n-1 freedom here, but you don't have to do that. We'll just do it over n. So what I'd like for you to get me the average, get me the average mean, the mean. Work it out on the table if you wish, and then also get me the standard deviation and variance. And by happenstance, you find the variance before the mean, or before the standard deviation, right?
Yeah. So
Okay.
just find those 3
The
things.
variance is
Those 3 things, yes ma'am.
the variance is what's inside the.
Inside the radical, in the radicand. It's part of the radicand. Absolutely right. Okay?
Right.
Radicand or radicand? I can, right? So, okay, now, I can't do nothing yet because you guys are seeing this, okay?
Yes.
But it's not, I can.
There's on the little button thing. There's like a little.
I'm gonna turn the lights on.
Yeah, that's fine, go ahead, thank you.
I cannot.
It's like a freeze button.
Is it on here? But this is on the internet. Oh, no, this is on, Word, right? It's not on the internet.
Well, it doesn't matter.
Freeze it on the projector.
You can freeze it.
You're right, you're right. Anybody know the freeze frame? Splits.
Should say like FRZ.
FRZ, he's right. All right, I froze it. You were frozen, right? It is not frozen?
Oh, no, we're about
It should say freeze on there.
Control. The button on the projector is for
See, we've got.
Say that again, please.
what?
She's gonna come on. All right.
We've got 9 minutes.
I'm still putting
The button
it.
on here freezes whatever you're projecting. So you can do it.
It's easier.
I have to use the thing. Yes. Fine. It's right there instead. Okay. So that means I should push this back then, this freeze button.